Good afternoon, everyone. Are you enjoying the first ever Java Summit here? Yeah? Me too. It's great so far. So my name is Sander Mak, and I am from the Netherlands, where I work with a company called Picnic. And yes, we do actually have these nice electric vehicles driving around in the Netherlands, delivering groceries to people. And not just in the Netherlands, we're also active in Germany and in France. Not yet in Israel, but who knows, that might change at some point. Anyway, I'm here not to talk about groceries. I'm here to talk about Java and technology. And I want to let you in on a little dirty secret of conference speakers. Because, we do like to talk about big ideas, new technologies. You need to do microservices, adopt this language, do this, do that. And it's not that they're bad ideas, but usually when you hear this, you can't really apply it in your day-to-day job, right? You're not going next week into your job and say, okay, guys, we're going to do it completely differently. So what I want to do instead in this talk is make it very practical. I'm going to teach and show you a superpower that you can bring back to your team tomorrow and that you can apply to any Java code base. I'm fairly confident of that. What is the superpower that I'm talking about? Because yes, Java developers can have superpowers. The superpower that I'm talking about is the ability to streamline, refactor, and improve your code base in an automated fashion at scale. And that is what we're going to be looking at in the next 45 minutes. Now, when I talk about refactoring at scale, I don't mean that we have many people just typing away in IntelliJ with their shortcuts, doing refactoring, etc. Don't get me wrong, IntelliJ is a great tool, but we need something where we can automate this. At least we needed something where we can automate this and we can make this part of our builds and we can make part of our development journey. So what instead we'll be looking at in this talk is indeed Google's error-prone project, which allows us, through code, to improve our code. And I think that's a superpower that's worth having as a Java developer. Now, this project is open sourced by Google many years ago. We adopted it, I think, 4 or 5 years ago in our company. We've also extended this. I will show this later as well. But all in all, it's a very important tool for us. But it's not that well known. How many people here have heard of error-prone before? Only a handful, right? And I think it's a pity because it's such a powerful tool and you can do many amazing things with it. So that's why I'm here and that's why we're going to change it in the next 45 minutes. Before we get started, why do we need this? As I mentioned, Picnic is an online groceries company. So we want to make online grocery shopping easy, fun, and affordable, which means that we own the whole chain. So we don't just have an app, but we also have fulfillment centers where people are picking groceries. We have these electric vehicles that need to be routed to people at the right time in the right place. So as you can imagine, we create a lot of software to make this happen in the backend. And even though it seems very seamless and easy from the customer perspective, there's a lot of logistics going on in the backend. And there's lots of things that we need to improve and schedule and build ourselves. So just to give you a picture, Picnic started as a small startup in the Netherlands in 2015, so just a handful of people. But now we have a tech team that is over 300 people strong. We're serving 2 million plus customers, many lines of code, and the majority of our code is Java-based. So we do have some Python code and some other languages in our stack as well, but the majority is built using Java. So as you can imagine, this enormous growth and this extension of the tech team can only happen if you actually take care of your code base and not just in the Boy Scout kind of way where on every pull request people start discussing and improving it. Yes, we also do code reviews, but we also want to automate this, right? And bring back all these learnings into our CI cycle, into our software development cycle in an automated manner. So this is a skill that we're talking about. This is also why this tool is so important to us. Now, when we talk about code improvements, code quality, etc., people often think of Sonar. And don't get me wrong, we use Sonar as well. It's a great tool. It's just a different kind of view on this problem. What Sonar can do is it gives you analysis of code, and then it tells you, well, you have 30 days of technical debt, 80 days of technical debt. And you're like, what does this mean, right? And do developers even look at this? And how do you bring this back into your development cycle and actually fix this? So in practice, we see a lot of broken windows if you just rely on Sonar for this analysis. We wanted to have something that is closer to the developer, that is closer to what we do in a day-by-day basis, and that's more actionable and more automatable as well. Now, of course, there's sort of a spectrum of tools here available to us as Java developers. So on the one hand, we have Sonar, which is great for the analysis. It is also great to see trends in your code. So that's something that we still use it for. It is not so great in actually day by day improving your code base, in our opinion. Now, there are other tools, right? So we have, for example, spot bugs. We have checkstyle. And these are actually very, very decent tools as well. But, I mean, they can also be a bit annoying, right? So they're just yelling at you and saying you're doing it wrong, which in the end, it's a little bit like eating your vegetables. We know it's good for us to use these kind of tools, but what do they actually do for us rather than just giving us errors? So if you look at error prone, it's a bit like the next step in this continuum, where we say, okay, it does indeed analyze our code, it points out problems, but as we'll see, it will also fix it for us, which is also a very important step towards automation of improving your code quality and encoding these things in a reusable manner. So what is error prone? Error prone itself is actually a Java compiler plugin. And many people are surprised. Can the Java compiler have plugins? Well, yes, it can. And error prone is a great example of that, where it hooks into the compiler and analyzes your code very close to where it's being compiled, giving it a lot of information and a lot of things to work with to help you spot problems. The nice thing about error prone is that it comes bundled, like some of the other tools that I mentioned, with a lot of predefined checks. So there are more than 500 predefined checks that you get out of the box when you add error prone as a compiler plugin to your Java build. And the nice thing is, since it's a Java compiler plugin, you can use it in any situation, right? So it doesn't matter whether you use Maven, Gradle, or some other esoteric build tool. As long as you can configure the Java compiler to use a plugin, then you're good. What was also very important for us is it supports recent versions of Java. So we are currently on Java 17 in our company, but it goes all the way back to Java 8 if you want to. I hope not, but anyway, it's a possibility if you need it. So these things combined gave us a lot of things to work with. And it's not just us, right? So if you go to the error prone website, you'll find this nice testimonial by Doug Lee, the guy who's behind the Java.IL concurrent libraries, where he says, well, it's a bit embarrassing. I guess I'm back to liking error prone, even though it sometimes annoys me. And then we get back to sort of the sentiment around these tools, right? They point out errors. But in this case, it actually found a problem in his concurrent hash map implementation, which otherwise would have gone unnoticed. So I think that's a very nice testimonial and something to keep in mind if you look at this tool and evaluate it. Now, of course, I can go on and on and on and talk about error prone, but I thought, why not just show you some code and some examples? So what I'm going to do is I'm going to go into the IDE and show you what it takes to add error prone to an existing Java project. And in this case, I have just a very simple Java project, a simple Maven project containing just this class. Now, looking at this code, do you see any problem with this? Just shout out, raise your hands if you see a problem. That's something that this gentleman there is exactly right. So we are creating an exception, the illegal argument exception, but we're not throwing it, right? So this is completely legal Java code. If we would just open the console and say Maven clean verify, then it will just compile all is fine. But actually, not all is fine, because in the end, we wanted to throw this exception. And what we can do is we can, as a first step in our project, add error prone as a compiler plugin. And I'm going to add it like this, where we set the compiler arguments of the Java compiler to enable error prone as a plugin. And for this to work, we also need to add the error prone dependency to our annotation processor path, so it knows where to locate this plugin. And at the moment, you also need to configure this compile policy to simple, because there are some assumptions in the error prone plugin about how the Java compiler internally works, which are only true if you configure this. There's an issue open in the JDK to fix this, to make this obsolete, but for now, you will need to do this to make error prone work. And by doing this, we actually have enough configuration to see error prone in action. So I'm going to run the same Maven clean verify command again. And this time it fails with an error. So let's see. What does it say? It says, okay, there's a compilation failure, which is interesting, right? Because previously it just compiled. Now with the new compiler plugin, it actually throws a compiler plugin. So it's not a Maven error or whatever. It's really the Java compiler saying, no, this code is not right. And it says, okay, there's a dead exception. There's an exception created, but not thrown. You can even go to the website of error-prone, where you will find an explanation on why this is a bad thing. But the interesting thing is, and this is where we already see that it goes a little bit beyond the spot bugs and the check style tooling that we know, is it actually gives us a suggestion for how to fix it. In this case, it's a relatively straightforward one, but it's really context sensitive, right? So you can see here that it says, did you actually mean to say throw, and in this case, new illegal argument exception, which is exactly what was there. And yes, error-prone, that is exactly what we meant. Now, if you look at this, you may think, well, it's now currently giving us an error, a compile error, but apparently it has a very good suggestion on how to fix this. So why not have this compiler plugin fix this for us automatically? And we can do that by, instead of running error-prone in this checking mode, instead running it in patching mode. And for that, we need to add some additional configuration to the error-prone plugin, where we configure it to run in patch check mode. We say, okay, for now, enable just the dead exception check that we are interested in. And then we can either have it emit a patch file in a certain location that can later be applied, or we can say, just patch the code in place, YOLO, right? And because it's a demo, let's do the in-place patching, because it's much nicer for the effect. So if we now run the same maven clean verify command again, and let's move back to the class just to see it in action. If we run it now, we will not get an error. And actually, I think, yeah, that is currently correctly configured. If we go back, it's actually rewritten to throw a new illegal exception, right? So I think that's pretty cool and pretty powerful. So we have a tool that knows about a bad practice. We can spot it very early, namely during compilation, using the error-prone compiler plugin. And then if we configure this plugin to run in patching mode, we can even have it patch this error for us. So that is the first step into using error-prone. All right, so let's move back to the presentation. And if you think about it, it actually functions a little bit like autocorrect on your phone, only in this case for your code, and I would say a bit more useful than the regular autocorrects that you usually struggle with. But that's sort of the mental model that you can keep in mind here, right? So there's a problem that occurs quite frequently that can be spotted by this compiler plugin, and it can fix it for you. Now, when you look at error-prone itself and all the predefined checks that are in there, there are different categories. So the one that we just saw, the dead exception one, is really a core Java kind of feature, right? But there's also checks in there for specific frameworks even at the moment. So of course, since it's a Google project, there's an Android check. There are multiple Android checks in there, actually. There are checks for JUnit. There's even for Java.IL, which probably says more about Google's code than about our code, because I don't think many people are using this library anymore. But anyway, it's in there. And if you are misusing in some way an API of any of these libraries, and there's a few more, then you will also get these errors pointed out to you by error-prone, and even fixes if you want to. So in that sense, it goes beyond just the regular core Java issues and checks that some other tools offer. Now, if you start enabling error-prone on your codebase and just have it apply all its checks, then you will probably see that a lot of things are flagged in your codebase, which is not a great starting point, right? And therefore, it's also possible to actually configure error-prone to only apply a subset of checks, or maybe down level or even upgrade the severity of some checks that are in there. And these configuration options are listed here. So you can get check name and then the severity. That's sort of how you configure this. If we are not interested in a check at all, we can turn it off. So in our code base, for example, since we don't do this on Android code, but we do this on server-side Java code, we just disable all the Android checks, because why waste CPU cycles on that? So that's the way to configure error-prone. Now, it might also be that you do want to enable a check, but there's a few exceptions in your code base that you can't just fix yet at the moment. And in that case, you can use the regular @suppress warnings annotation that you can also use to suppress regular Java warnings, to suppress specific checks that are offered by error-prone. And in this case, with @suppress warnings dead exception on the method that we just had, you would suppress this problem and it would not be flagged and it would not be triggered. It would not trigger the check in error-prone. So that is roughly the way in which you can introduce this tool into your codebase, right? So you would want to tune this at first and then gradually increase the amount of checks that are being applied while you fix and upgrade your code. Now, error-prone and as a compile plugin even goes a little bit beyond just spotting errors and bugs. There's also other functionality that can be built on top of this. And a good example of that is the var check that is built into error-prone. We use it heavily as well. So you probably all have this annoying coworker, right, who says, immutability is great. We need to make everything final in Java. And then you're like, yeah, I agree. It's great to work with immutable data, but putting final on all local variables and all parameters, it's a lot of noise, right? So do we really benefit from this? So what you can do if you have error-prone and this var check enabled is actually flip the defaults around for Java, where now when you run the Java compiler with error-prone and this check enabled, it will assume that all the local variables and all the parameters are final. And if you reassign, it will be a compiler error, unless you annotate it with @var. And this is a pretty nice way to invert the defaults and force yourself towards immutability without introducing all of the noise of having final everywhere. So that's a pretty neat way to see how error-prone also goes a bit beyond just spotting errors and doing sort of the same things as some of the other tools do. So we do have a few @var annotations in our code base, but usually not. And we do strive to be as immutable as possible in all of the things that we do. If you look at the ecosystem around error-prone, it is actually coming with a lot of bundled checks, like I said before, over 500. But there's more. You can also add additional dependencies to your annotation processor path. For example, one for Mockito, provided by the Mockito team, or one by error-prone, provided by the error-prone team, which have specific checks for the use of their APIs in these jar files. So you can extend sort of the amount of things that are checked by error-prone at compile time. But you may think to yourself, well, if these open source projects can provide these kind of checks, can we not do the same ourselves? And that's actually the next step that we're going to take with our error-prone adoption. So we first added it just out of the box with the default configuration, but we're now going to create our first custom check for error-prone, because this is a really powerful extension ability where you can actually implement your own checks and implement your own best practices inside of your company, inside of your team. And for that, you will need to create a class that extends the bug checker abstract class, where you are going to implement some checks, and we'll do a simple one first. But the idea is that this will be a separate Maven project that we're going to compile separately, and then we're going to add this separate project, which contains the bug check, to the annotation processor path of our original application and see how it will work automatically, because it will be picked up due to the service loader mechanism. We'll use Google's auto service to make this easy using an annotation. And this way you can see the extensibility of error-prone in action. And for that, I'm going to go back to the IDE, of course, where we still have our first project, but I'm going to switch to the second project, which is called My Bug Checker plugin. And as you can see in the POM, in this case, we are running the compiler not with error-prone enabled, because we're not going full inception and check our checks. But we do have the auto-service annotation processor enabled, so that we can use a simple annotation to make a class service loadable. There's some additional arguments that you need to add if you're on Java 17 or later to make this work. And importantly, we also need to add dependencies to the error-prone APIs, because we're going to code against their APIs to create this bug check. So what does this look like? We now have a very simple class called empty method checker. And what I want to do is I want to create a check that looks at any method in a class. And if there are no statements in there, if it's an empty method, I want to flag this as an error and say, okay, maybe we just want to drop this method. Now, to make this work, like I said, we need to enable this class to be service loadable. And we can make this very easy using the auto service implementation that Google provides. And then we need to provide some metadata in a bug pattern annotation. There we go. Say the name is, in this case, empty method, which is the identifier. We have a summary that we need to provide. So let's say we don't like do nothings. There we go. And we need to give it a severity. And let's just make this a compile error, just because we can. There we go. Now, all that's left to do is to implement this check. And error-prone works in sort of a visitor pattern kind of way, where it traverses the AST of code that's being compiled. And by extending bug checker, we can just override the method that is interesting to us. And in this case, we're only interested in looking at methods. So I'm going to override the match method implementation here. And what I'm going to do is say, okay, if the method tree that I'm getting, let's take the body, look at all the statements that are in there. And if it's empty, then we have a match. So then our bug check should trigger. So we can do this using the provided describe match method, which is also on bug checker class. And we can say, okay, this method tree, so this point in the AST, we're going to emit a suggested fix for that, which is to delete this method tree. There we go. And if not, well, then there's apparently no match. So we can keep going and just return description.no match. So what happens here is that we, in a visitor pattern, get offered every method that is being compiled. We can look at it and say, okay, well, if there are no statements, then we are going to emit this suggestion. And if we're going to Maven clean install this one, and we do need to install it because it needs to be in our local repository so that we can refer to it from the other project, then we can start using it if we refer to the coordinates of this project in our buggy app. So as you can see, there's a static do nothing method here, and we can go to our pom.xml, go to the annotation processor path, add an additional entry pointing to the bug checker that we just created. There we go. And now, if we go up, we run Maven clean verify, but first we need to ensure that we also enable this check. So we say empty method here. There we go. We run it, go back to my buggy app, and poof, it's gone, right? So this way, we didn't have to fiddle with any source lines of code, etc. We just had to manipulate and emit a suggested fix with the API. I can also show that it can work in checking mode. So I'm bringing back the empty method again, and I'm going back to the pom.xml, and we're going to not run in patch mode, but we're just going to run in check mode. Run the same Maven build again. And now we actually get our very own Java compiler error, which is pretty cool, right? So with just a few lines of code, we were able to add a check, which we found interesting, checking for empty methods. And it will just hook into the compiler infrastructure and emit an error for this check that we just created. And it also says that you mean to remove this line. And as we see, as we just saw, it is also possible to do this in patching mode, where it applies the suggested fix automatically. All right, so that gives us a lot of possibilities, right? And if you look at Picnic, how we use this, there's a couple of sort of categories of issues that we try to tackle with this. So there are a lot of things that you see a lot coming back in pull request reviews that are just annoying, and you can automate away using a tool like ErrorProne. For example, around handling time zones in your APIs. So we want to prevent people relying on the default system time zone. We want to force people to actually be explicit about time zones in every API that they use that is dependent on time zones. We also want to prevent people from, for example, from using system current time millis and local date time now, because these are all things that are untestable, right? So we would rather have people inject a clock instance, which can be mocked, etc. So these are things that we can implement using a bug check, and that can then be hooked into our builds and will be enforced across all of our code. Another area where we can benefit from error-prone bug checks is by looking at API users and spotting errors that might otherwise occur at runtime and try to prevent them at compile time. So one example is our use of S/4J. We use this as a logging library, and as you probably know, it uses the sort of accolades as the curly braces as a placeholder syntax. But sometimes people get confused, and they instead use the %s, which is the standard Java formatting placeholder, and hope that it works, which of course it doesn't. And this code will just compile. It will even just run without any errors. It just doesn't do what you would expect. And by writing a custom bug check that spots this, we can make sure that this is already caught at compile time. And say, okay, well, you're using this %s here. Probably didn't mean to. Please replace this using the curly braces. And a similar thing for if you provide a different amount of parameters, for example, for the logging statement, versus what you actually expressed in the log message there. So there's a lot of things that usually would compile and even run without error, but that just don't do what you want to do. And that is something that we try to prevent. So every now and then, there's new things that come up in a pull request review. If we see this coming back a couple of times, then for us, it's time to actually create a bug check that spots this and that can fix this for us. Another way where you can also use bug checks is also to enforce a bit more of a uniform code style. So for example, if you would have an annotation with just a single value and you use the value is syntax rather than just leaving it off, we would flag this. If you would have a list value inside of your annotation and only provide a single value, even you can have a trailing comma in there, which you don't really like. These are things that we can also flag using custom bug checks. So all in all, this is something that really empowers our developers to automate all the toil away and make pull request reviews much more focused on the actual functionality rather than on these kind of gotchas. So sounds good, right? But there's also a few downsides. In the previous examples of the checks of how we use them, you probably noticed that I only showed the header and not the implementation. That is because some of these implementations can be hundreds of lines of code. And it can be pretty tricky code because you need to know about the abstract syntax tree of Java code. You need to know how to traverse it, how to actually emit the right suggestions if you want to fix it automatically, which is all, it's doable, but there's a steep learning curve there. So working with ASTs can be challenging. And that especially holds true if you want to emit these replacements that we saw and that we also want to have. So what if we could take this even a step further, where we use error-prone to rewrite code, but in a way where we can express it such that we say, okay, here's a very concrete pattern in concrete Java syntax that we want to match, and here's what we want to rewrite it to, also just in concrete Java syntax. And then error-prone will just figure it out and make it happen for us. And that is actually possible if you use error-prone in combination with Refaster. Refaster is a way to express these rewrite rules in concrete Java syntax and then have them executed by error-prone, same way as these bug checks that we just saw are executed. So I'm going to show you a third and final demo of how you can use Refaster to achieve this. And for that, we're going to introduce yet another Maven project, which will contain this Refaster rule. And in this rule, we're going to express a before template, which is the code that we want to spot. So that's the buggy or the code that we don't like. And there will be a method annotated with add after template, which contains the code as we want it to look like after the rule has been applied. And when we compile this using a special annotation processor, we will get back a .refaster file, which contains sort of the instructions to do this for the error-prone plugin. Interestingly, we are not really interested in the class output of this whole process, so the class file resulting from compiling this will be ignored. We're just interested in the side effect of creating this .refaster rule, which we can then integrate back into our main application, which will take this rule and apply it on the code base that we compile there. So let's move back to the IDE again. In this case, to our third project. And just to show how it's structured, in this case, we're running the Java compiler with a different plugin called the Refaster rule compiler, which as a side effect emits this empty string.refaster file. And what we also need to do there is to add another dependency to the annotation processor path, which contains this Refaster rule compiler. So we were able to emit this .refaster file that's going to be used later. Now, if we look at the implementation of the rule here, we see that we can actually have multiple before templates. So what I want to do is I want to spot two patterns where people are trying to see whether a string is empty in sort of a roundabout way. So the first one that we want to spot is where people call some kind of string expression and then dot equals the empty string. And the other trick that people sometimes use is have some kind of string expression and then they call length and they compare it to 0. So these are two ways to see whether a string is empty, but they're both not really nice. Instead, what we would like people to write is the same expression, but then dot is empty, right? That's much more intention revealing, much nicer, and we would like to enforce this across all of our 5 million lines of code. Now, this is pretty straightforward, right? So it is not tricky. We're not traversing ASTs. We're just saying, okay, if you see code that looks like this, or like this, then just rewrite it to this. So if we're going to run the compiler here, we should, as a side effect, get the empty string.refaster file, and indeed, here it is, which contains sort of the instruction set for doing this using error-prone, but we don't need to care about what's in there because we can just provide it to error-prone and it will work as expected. Of course, we need to configure it, so I'm going to add the configuration for that, where, again, we're going to run error-prone in patching mode, but rather than using one of the built-in checks, I'm going to point to the empty string.refaster file that we just created, and I'm going to do in-place patching. Now, looking at this code, if you scan it, you will see an instance of the bug or of the pattern that we want to match, right? So here we have args0, which is an expression of type string, and then dot equals the empty string. So this is exactly one of the places where we would like to match, and we would like to replace it with the dot is empty. So if we're going to run this, here we go, and put the focus back here, poof, you see it's rewritten to dot is empty, which I think is a really, really powerful way of using your intelligence to look at patterns, encode it using refaster rules, and have it applied in automated fashion at large scale. So, of course, there are many, many other things that you can do rather than just this example. So to just give you a feel of how we use this at Picnic, we use these kind of refaster rules a lot, also when we migrate between Java versions. Because switching out the JDK to a newer version is relatively straightforward, right? So you just configure your code to run on, maybe in this case, Java.11 when we moved from 8 to 11. But moving just to a new JVM and a new JDK doesn't really give you all of the benefits of moving to this new version of Java. You would also ideally want to make use of the new APIs that are in there. Now, often you can say, okay, well, we're just going to do the Boy Scout rule. If you touch a piece of code and you see something that can be done in a nicer way in Java.11, then just fix it as part of the work that you're already doing, and then gradually we'll get a better code base. It works, but you will remain in a state of limbo forever, right? Because there's just some pieces of code that people don't really modify anymore, and these will be left behind. And once you move from 8 to 11 and from 11 to 17, you will have a very wide difference between different parts of code in terms of how they use APIs. So what we did and what we do is when we move to a new version of Java, we gradually also learn new patterns and new APIs, and we encode these using refaster rules. So for example, in Java 8, you would only have the is present optional, right? So if you wanted to check if something wasn't in an optional, you had to say not is present. Now, in Java 11, we got optional is empty. So what we did is we created this refaster rule where we say, okay, just match anything where you see not optional is present. And again, the optional here can be any expression of type optional, and just rewrite it to is empty. Again, much more intention revealing. It's not an earth-shattering change, but by doing this consistently across all of our code base, we set the right example. We move to the JDK and actually start using its new features. And yeah, I think all of our development is the better for it. Another example of this migration where we also use refaster and where you can also see that it's not just core Java, but here we match, for example, against a pattern where you say if there's some stream and you call filter on it, where you first filter on is present and then map optional get over it, just to get all the non-empty values out of a stream. Or if you do the same using the streams : stream method that is in Guava, we are also Guava users, then rewrite it to stream.flatmap optional stream, where stream is a new method on optional that was introduced in JDK 11. Again, now we have a code base where previously it was done in two different ways. We can do it in a nicer way in Java 11, in a way that's part of the platform, so we can just rewrite it at scale at once. Again, it's not just limited to core Java APIs. We are also project Reactor users. So there's a lot of patterns in there that people fall into that we can also catch using refaster rules. And here's just a simple example where people do some wrapping. That's not really necessary. And again, you can also see that you can have multiple free variables in this kind of rewrite rule, where the object here is just some type S. We don't really care. And then we rewrite the then method to then return, passing in just this object expression. Again, if you don't know Reactor, probably doesn't make sense, but it's just here to illustrate that it's about being able to use both core Java, but also your libraries correctly. So when we use Refaster? Well, Refaster is really a rewriting tool, whereas our bug checks that we just created can also just be spotting some issues and pointing it out to you without necessarily rewriting. And if you have this expression-based, fluent kind of chain of method invocations, those are sort of the sweet spot for Refaster rules to write them and to make best use of them. You can also pattern match against consecutive statements in a method. It's a bit more, I would say, finicky, because how often do you really have the same pattern of statements, etc., in a code base? For us, it's mostly applicable to these fluent chains of methods that we want to migrate. But if you look at both, there's definitely a place for both Refaster rules and bug checks. So on the one hand, Refaster is much easier to work with because you can just write Java code and all of the magic happens under the hood. Whereas if you're going to write a bug check, as we saw, you need to know a bit about Java ASTs. You need to be able to work with the error-prone APIs to emit suggestions. So that is something that you need to account for as you start adopting this tool. So Refaster, refactoring only, whereas bug checks are much more general and much more, I would say, generally applicable. Now, you might be wondering, okay, so you showed us the Refaster rules, the bug checks, everything around that, but how do you actually integrate this into your development cycle? So at Picnic, we have a special profile in our Maven builds, which developers can enable, which runs error-prone in checking mode and will flag any violations that you make. Obviously, we also provide ways for people to run error-prone in patching mode locally so that they can actually commit the fixes that they want to commit. But let's say you don't do this and you just push your code to a branch and there's still some problems in there that need to be fixed. So what happens then is that in this branch build, we will run the code in patching mode with this error-prone Maven profile enabled. And if there is any change at all after running error-prone in patching mode, so all of the Refaster rules have been applied, all of our bug checks have been applied, and if there's a non-empty diff, it means something was missed. And what we're going to do in that case is we're not going to automatically commit this because we don't want to make any assumptions here. We're just going to block the PR from being merged. And we post a comment there saying, okay, there's been violations, please check this out. And then it's up to the developer to actually see, okay, yeah, do we actually want to fix this? Usually yes, so they can run it themselves and commit the results of patching and running error-prone in that mode. But sometimes you might also say, okay, well, in this case, I just want to suppress this warning because there's a special circumstance. So it's really still a developer choice on how to use a tool. But in the end, every situation needs to be resolved either by accepting the suggested fix and committing it, or by adding a valid suppression for the problem if it's the way to go. So this way we are 100% sure that anything that is merged to our main branch always conforms to all of the rules and Refaster rules and bug checks that we have as part of our code base. So if you look at the error-prone website, there's some guidance on there if you want to create these bug checks yourself. In the end, the goal here is to create simple, small, understandable checks. So they should not do 100 things at the same time. They should be composable, should have no false positives. There's a lot of things that you need to be mindful of when you create these bug checks and rules. So that in the end, people who use this actually think, well, I'm happy that this error-prone check caught this for me. So that in that way, that's the way sort of to think about how to leverage and use this tool. So I talked a lot about error-prone as it comes from Google, as you saw, and how we created a lot of bug checks and Refaster rules. It's very nice that I can also share with you that we actually open sourced our extensions to error-prone. So all of the checks that I mentioned, so SLF4J and all of the other ones, we push this into an open source project called error-prone support. If you go to errorprone.picnic.tech, you will see a site where you can find many additional bug checks and even more of these rewrite rules, including the JDK 8 to 11 and 11 to 17 rules that you can use on your projects by just adding error-prone support as an additional dependency to your annotation processor path. If you go to the site, you will see that we also create very nice documentation around all of the bug checks, what it actually checks for, and what it can do for you. As you can see, we also have rules around, for example, using AssertJ, JUnit, all kinds of useful and current libraries. And also for all of the rewrite rules that we have before and after examples. So hopefully this can also help you in your adoption of error-prone by not just having the Google out-of-the-box and bug checks, but also having a lot of Refaster rewrite rules that have been proven in practice and have provided a lot of value to us. We also have some performance improvements and some other tweaks that we contribute to error-prone. So in that sense, if you are thinking about using error-prone, definitely as a first step, just start using error-prone from Google out of the box. But once you get the hang of it and thirst for more, I would really recommend also checking out error-prone support and taking that into account as another way of bringing even more power to your codebase at scale. So now it's actually up to you, right? So I've shown you the superpower. I've shown how easy it actually is to add the error-prone compiler plugin to your build, and how you can even extend this to include your own checks and your own rewrite rules. So again, if you want to make the most use out of this, first go to errorprone.info. But after you've absorbed that and implemented that, highly recommend also going to our error-prone support open source project. This QR code points to a quite extensive blog post, also detailing our story of how and why we adopted this tooling, giving you a sort of a bit of a background on how this came to be. If you have any in-depth questions and want to geek out on this even further, you can either do this on our open source project, Open Issues, but you can also contact Stefan or Rick, who are part of our Java platform team at Picnic, where they are still heavily developing this and making sure that we actually extend this in a meaningful way. So just to give you the organizational picture, we have a Java platform team at Picnic that takes care of creating these kind of rules and these bug checks, which are then enabling the rest of the company to create code and to refactor code at scale. And the interesting thing is that a lot of our product teams also start contributing back towards this error-prone support library. So you see a lot of people who in their teams see recurring issues in pull request reviews. And at that point, they decide, well, enough is enough. Let's try to encode this either as a bug check or as a refaster rule. So that's sort of the way in which this organically grows within the company. And I think this can work for a lot of companies. This model is really scalable and really also enticing for developers, because in the end, it's all code, right? So who doesn't want to automate away a lot of the annoying discussions and issues on pull request reviews? So this is a way to do this. Now, happy to answer any questions after the talk. I'll be here around, also in the break, of course. If you want to build on this cool stuff with me, definitely also go to this website. I highly recommend checking it out. Other than that, I want to thank you all for your attention and wish you also a great lunch.